Good day everyone. To this video we're going to discuss what is belt and pulleys. So it is expected at the end of this video we're going to know and we're going to differentiate the types of belts and pulleys and how belts and pulley works in our industry. So fasten your seatbelt guys and let's explore the world of belts and pulleys. In one way or another, power must be transferred from one source of energy to another in mechanical device. The most common and the cheapest form is to use belt and pulley. So this power is either gathered from an electric or mechanical generator to transfer rotational motion to the application. So the primary function of a belt is to transfer power from one source of energy to another, whereas pulley, it has groove around its circumference that allow a belt to smoothly through it when transmitting rotational motion. Diagram is a two-pulley system diagram. It is consists of a driver wheel and a driven wheel. So it is ang patuyok niya kay ang motor. So driving pulley is the input pulley of a two-pulley system. So this is the pulley whose shaft is being driven by something like a motor, crank, or possibly by another pulley if in larger system. This pulley is what is controlling the motion of the belt. So undriven pulley is the output pulley or the two-pulley system. This is the pulley that is being turned because of the belt's motion. Belt and pulley can be used in, first, automobiles. It is connected at the crankshaft of an automobile. Next, belt and pulley can be used in belt drive generators. Not just belt drive generators, but also stationary generators. So belt and pulley can be used in marine engines and also in the aviation engines. Pulley also can be used in air compressor engines and also agricultural equipment just like tracers, tractors, and water pumps. So belt and pulley can be used in escalators and elevators. So our escalator and elevator cannot function without the use of pulleys. What is belt? Belt is a loop of the flexible material used to link two or more rotating shafts mechanically, most often parallel. Belts may be used as a source of motion to transmit power efficiently to track relative movement. Belt types. But before that, all power transmission belts are either friction drive or positive drive. Friction drive belts rely on the friction between the belt and the pulley to transmit power. They require tension to maintain the right amount of friction. Flat belts are the purest form of friction drive, while V belts have a friction multiplying effects because of the wedging pulley application. So next, positive drive, or also known as synchronous belt. So rely on the engagement of the teeth on the belt with the grooves on the pulley. So there is no slip with this kind of belt except for ratcheting and tooth jump. First type of belts are also known as flat belt. Flat types of belt are used where low power and more speed is required. They are rectangular cross-section types and the shaft distance must be between 5 to 10 meters. So the efficiency of this drive is around 98% and produce a little noise. The common flat belt applications, first, grinders. So flat belts are used in grinders. Second, wood planers and flat belt conveyors, and many more. So the next type of belt are also known as round belt. So round belts and O-ring belts are light to heavy duty power transmission belts. So these belts are also called endless drive belts or endless round belts. Round belts are solid or hollow lengths of cylindrical material. So they maintain contact with the belt pulley using friction and must stretch elongated to operate. So round belts and O-ring belts are commonly used in typical power transmission applications such as round belts conveyors and also packaging machineries. Then it is also used in photocopier and printers and also in imaging equipments. The next type of belt are also known as the V-belts. So the V-belt types are used where shaft distance is less than 2 meters. They offer more speed and high power, unlike flat belts. So V-belts are trapezoidal cross-section. Multiple drive are possible in this type of belt. So the V shape makes it easier to keep fast-moving belts in shape grooves than it is to keep a flat belt on a pulley. So the biggest operational advantage of a V-belt is the wedging action into the shape groove. So This geometry multiplies the low tension force to increase friction force on the pulley sidewall. Over the course of time, different types of V-belts have developed depending on the application. The first type of V-belt is called standard V-belts. It is also known as classical V-belts. It is standardized in Germany according to DIN 2215 and have a height to weight ratio of 1:1.6. Tension cords are made of steel, aramid, polyester, or glass, are embedded in an elastomer core covered by a top layer. Next type of V-belts is also known as narrow V-belts. Compared to standard V-belts, narrow V-belts have a height to weight ratio of 1:1.2. The greater the height ensures greater power. So this is an example of a narrow V-belt and a standard V-belt. So mas lapad ang standard V-belt, no? Mas taas ang narrow V-belt. This type of V-belts is also known as the banded V-belts. If several individual V-belts are connected to each other by a cable plate, this is referred to as the banded V-belts. Such a combination of several V-belts ensures, among other things, that individual V-belts do not jump off the pulley under the impact load. So, isumpay man sila. V-belts are also used in industrial machineries, so such as HVAC units. So HVAC means heating, ventilation, and air conditioning. So it is also used in compressors, metalworking machineries, and many more. Walang nakag-include kay taas na kaayo. Next type of belt is also known as the synchronous belt. Synchronous belt have a tooth profile that mates with the corresponding groove in the pulley, providing the same positive engagement as the gear or chain. So synchronous belt can wear rapidly if the pulley are not aligned properly, especially in long center distance drive, where belts tends to rub against the pulley flange to prevent the belt from riding off the pulley. One of them is usually a flange. So a recent development has produced a belt and pulley that has a V shape instead of a straight tooth shape. So it runs wider than the other shape and it doesn't require pulley flanges. So synchronous belts are used in the automobiles. So it is located where the crankshaft or the camshaft is, or it is also known as a timing belt. A belt is also known as a link belt. They are made from interconnected links that can be customized to any length without using tools. They are typically used to replace standard V-belts, eliminating the need of stock different lengths of V-belts and lowering maintenance costs. These belts can transmit the same horsepower as the classic V-belts. Types of belt drive. But before that, what is a belt drive? So the rotation of motion is the ideal and the simplest means of transmission of the mechanical power with negligible losses. Rotational motion can be transmitted from one mechanical element to the other with the help of a certain system known as the transmission system, or also known as a drives. So that is a belt drives. So in a two-pulley system, depending upon the direction the belt drives the pulley, the belt drives are divided into two types. The first type is the open belt drive and the second type is the cruise belt drive. This image shows what is an open belt drive. In this type of belt drive, the belt is employing when two parallel shafts have rotated in the same direction. When the shafts are far apart, the lower side of the belt should be tight side and the upper must be the slack side. This is because when the upper side becomes the slack side, it will sag due to its own weight, thus increase the arc of contact. So this is a cross belt drive. So in this type of belt drives, the belt is employing when two parallel shafts have rotate in the opposite direction. So at the junction where the belts cross, it rubs against itself and wears off. To avoid excessive wear, the shaft must replace at a maximum distance from each other and operate at a very low speed. So dapat hinay lagi kini siya mag-operate nga kayan sa belt drive. So,
Hi everyone. So today our topic is about pulley. Pulleys can be found everywhere to help make our task easier. So originally, pulley is a simple machine. To make a brief history, pulley earliest evidence was around 15,000 BC in ancient Mesopotamia, where they used rope pulley to lift a bucket of water. So what is pulley? Pulley is a wheel having a plane or groove rim, which can be found on the side, which the belt runs for the transmission of power from one shaft to another. So basically, pulley is made up of a wheel and its driving element, it could be a belt or other. Pulleys also can be called as sieve, drums, and it may have groove, single groove, or a lot of grooves. So what are the uses of pulleys? Pulleys are used in variety of ways, like to lift loads, since the pulley reduces the amount of force required to lift a load. It could also be used in applying force, either in horizontal or in vertical. It can also transmit power from one pulley to another or from the direction of pulley to the application that requires a power. Some of the examples of pulleys in our times include elevators, escalators, crane and bulldozer, flagpoles, cargo lifts, exercise equipments, and many more. Now let's proceed to the materials and driving element of pulley. Pulleys are made up from cast iron, so which is widely used because of its low price. It could be also a cast steel with higher strength, lighter in weight, and can run at higher speed but have lower coefficient of friction compared to cast iron. It could also be a wrought iron or aluminum with high resistance of corrosion, and it could also be a wood that is lighter and have higher coefficient of friction. And lastly, it could be a paper for a smaller center distance to transmit power from electric motors. The driving element of the pulley helps the power to transfer from another. It includes like rope, cable, belt, chain that runs over the pulley inside the groove or grooves. But how does a pulley work? A pulley is a simple machine that consists of driving element like a rope or a belt and its grooved wheel. So the rope fits into the groove on the wheel, and by pulling the rope, the wheel will turn. And then the object that is being lifted is known as the load. A pulley allows you to reverse your direction of lifting force by pulling down the rope while lifting the load on the other side. So it is reversed, like you pull it down and on the other side you lift the load up. With two-wheel pulley, you reduce the force you use to lift the same amount of load. As you can see in the picture, with the use of two-wheel pulley, you lift the weight with half of your strength. The force needed gets smaller to lift the same weight of load using three-wheel and so on in the fourth wheel. This shows that the more wheels you have and the more times you loop the rope around them, and the more you can lift the load. This is known as a mechanical advantage or ME. So while you are using a two-wheel pulley, this means that you have the mechanical advantage of two. So the bigger the mechanical advantage, the less force you need to lift a weight. As you pull the rope, the lower and upper axes slowly come together, increasing your ability to lift the object. Now let's proceed to the components of pulley. The first component of pulley is known as the rim. Rim is the periphery of the pulley in which the belt runs. So if this is a pulley and we would draft it or sketch it, so the rim is located at this part, which is the side of the pulley. And if we're going to look at the cross-sectional view of the pulley, this is the rim and the belt is mounted in it. The outer face of the rim is made of slightly convex, which is called the crowning. So the crowning helps prevent the belt from running off the pulley by bringing it to the middle plane of the pulley whenever it moves to the side. So basically, the purpose of the crowning is to keep the belt in equilibrium position near the center of the rim. The next component is the hub or the boss. The hub is the central hollow cylindrical portion of the pulley. So if we're looking at the pulley in the graph, so this is the hub, and then the size of the bore, which is the hole in the middle of the pulley, that part is the bore. On the hub correspond the diameter of the shaft. The hub is mounted on the shaft, and the keyway is provided to fasten the pulley to the shaft with the help of the key. So the shaft is inserted in the bore. That's why the bore corresponds to the diameter of the shaft. As you can see, there is a rectangular part here. This is known as the keyway, where the key is inserted to fasten the pulley and the shaft. The third component is the arm or rib. So the arm is the joining member of the hub, and it serves as the rib of the pulley. It may be a straight one or a curved one, or its cross-sectional may be a circular or elliptical. So in some pulleys, instead of their using arms, they use web to join the hub and the rim. So as you can see here, it looks like a solid circular. Let's proceed now to the types of pulley. So the first type of pulley is called the solid pulley. It is made from single piece of cast iron and relatively small in size. It can be mounted in the shaft by inserting from one end. So it is used in increasing and decreasing the speed or the torque utilized for transferring power. The common application for this type of pulley is known as exercise and fitness equipment. The second type is split pulley. Split pulleys are made up of halves and provided by bolts through the flanges and half for holding the halves together. So it is split into half. That's why it is also called as parting pulley. So it can be mounted on the shaft at any place without changing the assembly of the bearing and shaft. The application of this type of pulley includes electric clutch brake with high-speed mower application and also car engine. The third type of pulley is known as step or cone pulley. It is used when the speed of driven shaft is to change frequently. So it is a cone shape that allows the pulley operator to transfer the speed of pulley's movement, requiring less work with smaller circumference since it is a cone shape. So as you go up, the circumference getting smaller, but it produces less work. So it has integral casting, having 3 or more number of pulley with different diameters, and it is a cone shape. Common application of this type of pulley is a multi-gear bicycle and a milling machine. Number 4, the fourth type is fast and loose pulley. So this is the combination of two kinds of pulley. The fast and loose pulleys are used on the shaft that enables the machine to be turned on or turned off. Fast pulleys are mounted on the machine shaft while the loose pulleys operated independently. And these two types of pulley can vary in size. Like for example, the rim of the fast pulley is made larger than loose pulley for the reason that the belt runs slower in the loose pulley. The loose pulley usually has also longer hub to reduce wear and friction and requires proper lubrication. The power also is transmitted when the belt is on the fast pulley, while the loose pulley is only in charge of the idling of the machine but do not transfer power at all. The application of this type of pulley includes lathe, which is a cutting machine, and a centrifugal water pump. The fifth type of pulley is known as a jockey pulley. It is an idler pulley that is used in the steering section of the system that increase the angle of contact in an open belt. So it is mounted near the smaller pulley of the two pulley and is placed in the slack side, meaning the loose side of the belt. The function of this pulley is to increase the angle of contact of the belt. So this also help increase tension of belt and also offer high velocity ratio of the drive. The common application of this type of pulley is trailer, and it can also be found on the bicycle where derailleur. The sixth type of pulley is known as the guide pulley. Guide pulleys are used to guide belts when connecting non-parallel, intersecting, or non-intersecting shaft. It is usually used to guide cables and keep it along a specific path. So the application of this type of pulley includes in a crawler crane. The seventh type of pulley is groove pulley. Groove pulleys have V-groove, or it could also be a circular groove on its rim, and it carries V-belt or rope. This type of pulley is specifically designed for V-belt. So it ensures the belt grips on the wall of the pulley for greatest traction and torque. The common application for this type of pulley is fan, dryer, pump, microwave oven, dispenser, chairlift, and washing machine. Now let's proceed to the computation. Central distance between pulley. Center to center distance between pulley is denoted as CC, with the formula given CC is equal to 4 times L. L is the length of belt, minus 6.28 times the sum of the diameter of large pulley plus diameter of small pulley plus the square root of the quantity 4 times the length of belt minus 6.28 times the sum of the diameter of large pulley plus the diameter of small pulley quantity squared minus 32 times the difference of the large pulley minus the diameter of smaller pulley quantity squared, all over 16. For example, in this problem, the diameter of small pulley is equal to 100 millimeter, and the diameter of large pulley is equal to 200 millimeter. The length of the belt is equal to 1,675 millimeter. So we're looking for the center to center distance. So by using the formula, we would substitute the given. So we would come up with CC is equal to 4 times 1,675 minus 6.28 times 200 plus 100 plus the square root of 4 times 1,675 minus 6.28 times 200 plus 100 quantity squared minus 32 times the square root of 200 minus 100 all over 16. So we would get 4,816 plus the square root of 23,193,856 minus 320,000 all over 16. So the CC is equal to 599.92 or approximately equal to 600 millimeters. So that's how you're going to solve the center to center distance of belt drive. Now let's proceed to the length of belt. So there are two types of belt drive. It can be an open belt drive or a closed belt drive. So let's focus first on an open belt drive. Let's determine the required length of that belt drive. With a given formula, L is equal to 2C, which is C is the center to center distance, plus pi over 2 times the sum of the diameter of large pulley plus the diameter of small pulley plus the square of the difference of the diameter of large pulley minus the diameter of small pulley all over 4 times the C, the center to center distance. For example, in this problem, an open pulley running over two pulley, 240 millimeter and 600 millimeter diameter connects 3 meter. Determine the length of belt required. So we have the given. We're looking for the length of the belt drive, L. So this is the diagram since it is an open belt drive. So by the given formula, we would substitute the given numbers. So the length of the belt required is equal to 7,330 millimeter. Now let's proceed to the second type of belt drive, which is a closed belt drive. To find the length required of the belt is the formula L is equal to 2C plus pi over 2 times the sum of the diameter of large pulley plus the diameter of small pulley plus the diameter of large pulley plus the diameter of small pulley quantity squared all over 4 times C, the center distance. For example, in this problem, two pulley, one 450 millimeter diameter and the other is 200 millimeter diameter. And the parallel shaft 1.95 meter apart, connected by a closed drive. Find the length of belt required. So we have the given and we're asked to find the required length of belt. So this is the diagram. By the given formula, we will substitute the given we have formulated. So the required belt length is equal to 4,975. Okay, next is the diameter and speed ratio. So speed ratio is denoted by N1 over N2, where N1 stands for the speed of smaller pulley, usually the driver pulley, as you can see in the picture. And N2 stands for the speed of large pulley, which is usually the driven pulley. The speed ratio is equal to the diameter of driven pulley divided by the diameter of driver pulley. Then we also have the output speed, which is calculated in the formula. Output speed is equal to input speed over speed ratio. Okay, for example, in this picture above, we have a driver pulley which has a diameter of 200 millimeter and a driven pulley which is equal to 600 millimeter. So 600 divided by 200 is 3. So we can say that the ratio is 3:1. The driver pulley revolves 3 times while the driven pulley revolves once. For the output speed, since the speed of the driven pulley is not given, we can calculate it using the formula of the output speed, which is equal to the input speed divided by speed ratio. So the input speed of the driver pulley is equal to 90 RPM, revolution per minute, divided by the speed ratio 3. So we have 30 revolution per minute. So the output speed of the driven pulley is equal to 30 revolution per minute. The other calculation involves the arc of contact. This is for the flat belt pulley. So it has this formula, pi plus minus sine inverse radius of the large pulley minus radius of smaller pulley over the center distance, or equal to pi plus minus d diameter of large pulley minus the diameter of small pulley over c. By the way, the signs plus is used for the sign of large pulley, while minus is the sign used for smaller pulley. We also have tension in belt, which is neglecting the centrifugal tension. We have F1 over F2 is equal to F C theta. Power transmitted by belt. We also have the torque, the power, the stress in belt, calling the horsepower, and the beat. Okay, so based on the problem, the givens are D, the diameter of 610 millimeter, P, the power, which is 37 kilowatt, N, which is the speed, 600 revolution per minute, theta, which is the arc of contact, 144 degrees, and then mu, which is the coefficient of friction, 0.35, and the S, the working stress, which is 2.1 megapascal. So the first is we need to find the tangential force. So the tangential force, if you could recall, it is denoted as F1 minus F2 based on the formula on the previous slide. So in order to find that, we would combine these three formulas for the power, the torque, and the velocity. So the first thing we would do is to substitute the torque in the formula of the power. So it goes like P is equal to 2 pi times F1 minus F2 times R and N. So if you would notice, we have 2 pi R and N. So 2 times R is just the diameter. So pi, the diameter, and the N is just equal to the velocity. So P is equal to F1 minus F2 times V. So power can be equated in force times velocity. So in order to find the tangential force, so tangential force is equal to power over velocity. So just substitute the given. So we have F1 minus F2 is just equal to, we will follow the unit of kilowatt. So if we would use kilowatt, then the final force will be kilonewton. So substitute 37 over the velocity pi times the diameter, convert it into meter, 0.61 times the N, 600 RPM, so we need to convert it in seconds, revolution per second. So we need to times this one with 1 over 60. So F1 minus F2 is equal to 37 over pi times 0.61 times 600 times 1 over 60. So F1 minus F2, or tangential force, is just 1.93 kilonewton. So now let's proceed to the second problem, which is find the effective belt pull. So the effective belt pull is just the letter F here in the torque. So in order to get that, we need to solve first the torque here in the equation of power. So just directly substitute based on the given. So P, we have 37, which is equal to 2 times pi T, which is our unknown, times our N, 600, and we would convert it to seconds. So 1 over 60 since it is expressed in minute. So T is just 37 over 2 pi 600 times 1 over 60. So T is equal to 37 divided by 2 pi times 600 times 1 over 60. So we can get 0.58887. So we will recall it for more accurate value. Shift, restore to A. So like that. Oh. So we will substitute this one in the torque equation since we already have the value of torque. Now we are going to find the F. So just substitute the T. 0.58887 is equal to F times the radius. A radius of this one is just 610 divided by 2, but you would express this one in meter. So we'll have 0.61 over 2. So F is just equal to 0.58887 over 0.61 over 2. So F is equal, we will use now what we restore. So we have alpha A over 0.61 over 2. So F is just 1.93 unit kilonewton.